Thank you for everybody for coming. It's nice to see so many people here. My name is Deepak Singh. I own the Amazon EC2 container service, which we announced at reInvent. And Dan here is one of the devs on the team. A small bunch of us, most of whom are here, helped get this thing off the ground. What I wanted to talk about today was the following. Like, a little bit about why we built the container service, what it is, and after that, I will step out and let Dan do all the hard work and talk about some of the key components of the service, a little bit about schedulers, and actually walk you through how you could potentially use the EC2 container service, give you a flavor of how you might run applications with it. And hopefully that will be the meat. And if we have time at the end, we can do Q&A. We'll be around at the end. At least some of us will be to take questions then as well. Just to get started, not surprisingly, folks have been running containers in general, Docker in particular, on EC2 for a very long time. Before we started the container team, I used to own product management for the EC2 server platform for instances. And we kept getting questions once Docker came out. So I think about 3 months after Docker got announced about, hey, there's this Docker thing, and what are you going to do about it? And I think I just blew the fuse. OK, back. Awesome. Excellent. Laptop still alive? Yes. So part of what we wanted to understand were what were people doing, what was different about Docker at the time. It's pretty new. Why in the years that LXC had been around, any of the other container technologies, and nobody had really come and asked us to develop a service to run those. So we started digging into what people were doing, and this should not be surprising to anyone in this room. There's a bunch of folks who are super interested in Docker because of what it gave them for configuration of instances, to deploy their code to instances, to start building CI pipelines, where they get this consistent experience across from their laptops onto production instances. Typical fare, not super surprising. I think what was very interesting was the number of people who had started breaking up their applications into little services. And I think Docker came at just the right time for them, because there were folks who were already doing it. They were doing it in, some of them were using things like LXC and OpenVZ. Others are doing it in JVMs. There are various ways that people are trying to develop these microservices. And Docker came along, and it provided the kind of interface and artifacts that made it very easy. Well, I think it attracted a lot of the same crowd. And I think this is where we've seen perhaps the most interest amongst our customer base is in this particular use case. And I think the third one was batch processing. So we have a number of folks who do analytics processing on EC2. A good example here is there's a company that does sequence analysis on EC2 that historically used spot instances for opportunistic computing. And recently, about a year ago, when I spoke to them, they had started using they just started using Docker. Yeah. So they had just started using Docker, and what they were basically doing was combining spot instances with trying to do opportunistic, hey, I have all these applications that I want to distribute onto a cluster when there's resources available, and I'm going to mix and match, trying to do it on the cheapest possible instance that I get with, I need to do it when there's resources available for me to do it. And it was a pretty compelling model for them, and we ran into a number of other people doing all kinds of sort of batch processing, data analysis using Docker as a way to encapsulate tasks and distribute them. Again, not super surprising if you look at the history of how people build distributed clusters, but there we have it. So we went back to the drawing board and said, OK, so why do we need a service that's a native service to manage Docker, to do Docker orchestration on EC2? There's folks who are doing it today. There's some good frameworks out there that people are using. Some had built their own. What we really wanted to do was make running Docker enabled applications awesome. And what did that mean? And that's what we started to build. And over the next few slides, I'll describe sort of what the core tenets of the EC2 container service are.
You've lost your slides.
Oh, well, thank you. Let's try that again.
There you go.
Thank you. So the first thing that the first decision we made was we wanted to build a low-level service that people could use to build high-level applications and services on top of. It wasn't just about, hey, I just want to run containers. It was more about what are the APIs and what are the primitives that we can provide people so that they can build more complex services on top of us. That came from both our customer base outside Amazon, as well as from services inside AWS and Amazon that wanted to take advantage of the capabilities that Docker gave, and they wanted a set of native APIs to do that. What the EC2 container service is essentially one of the core functions it has is cluster state management. You'll get a good example of the state management capabilities of the container service, but one of the key goals was there's a whole bunch of folks spending a lot of effort trying to figure out how to scale their cluster management systems, scale their state configuration management systems. I have a small one when I'm running a few containers. But what happens when I'm running 10,000 containers across a few thousand instances? How do I scale my management infrastructure for that? And so the answer we had was you don't have to run any. Everything is an API. You want to manage your cluster, you do it with APIs. You want to get the state of your system, it's an API call or two away. That was another key thing that we wanted to do. Obviously, the other part is we manage containers, we keep track of them, we help you figure out where they're running, what they're doing, start them, shut them down. And we help you schedule them. In a little bit, we'll talk a little bit about the various ways you can schedule containers onto a cluster with the EC2 container service. But that was another key feature we got. Initially, actually, when we started thinking about the service, our first take was there's a whole bunch of schedulers around. People will figure it out themselves. And it became pretty clear that people wanted us to take that problem away as well, at least a certain class of people. We needed to perform, which means that the launch times of your cluster and the management and the response times shouldn't change that much, whether you're running a few containers or you're running lots and lots of containers. So that was a big part of what we built. And given the type of customer that had expressed interest of using such a service on AWS, there are a few things that they wanted. They're running in production. There were also a bunch of enterprises that, and this is one of the nice, interesting things about Docker, at least in our experience, was a number of large enterprises that showed interest. And these were companies that probably didn't adopt Linux for years. So it needed to match their security posture. And the key decisions we made for that was the container service actually runs on instances. You're using instances that you own, so you launch them. These are your containers. It's going to be fun. Grab a drink.
The presentation's just too awesome to keep them confused.
The fuse keeps tripping over here.
It's everyone on Wi. Excellent. And so the containers are also owned by you. They're not being so we are not. It's not abstracted away from you quite like that. And the other key requirement was, for those of you familiar with EC2, is we have this networking concept called the virtual private cloud. It's a networking infrastructure that's actually default for any new customer that gives you a lot of interesting capabilities on network isolation. And that's a requirement. The EC2 container service requires you to run your instances inside a VPC. And as I said earlier, one of our core goals was to build a low-level service. So everything is an API. Everything that you want to do with the service is through APIs. So you can build on top of it. You can extend it. You'll see examples very shortly of how there are components of our service that you can actually modify and submit pull requests or issues on, which potentially can extend them as well. And what it means essentially is we took running Yeah, I know. Hang on. Yeah, that's right. Let's try that again. Yeah, but when it goes to slideshow, it tends to go. When it goes to slideshow, it tends to disappear.
Your image is probably like screwing up the drivers.
Okay, the slide that you missed was a slide that said that, essentially what we wanted to do was build a set of first-class APIs where containers were not necessarily some kind of overlay that sat on top of EC2, but a core set of APIs that you treated like infrastructure. You could use to build complex applications. You could use to build platforms inside your company. You could use to build all kinds of platform and management applications on top. And our assumption and hope is that there'll be a whole bunch of people building interesting applications, interesting services, interesting platforms on top of the APIs that we have developed. Now, for the more interesting and meaty part of the talk, I'll hand this over to Dan, which should be interesting given he has to use both his hands. But you can probably yell. Yeah, this will go with the mic.
All right. As Deepak mentioned, my name is Dan Gertismeyer, and I'm a software engineer on the EC2 container service team. To give me kind of an idea with the audience out here, how many people have gotten an opportunity to try out EC2 container service? All right, so just a handful. So I'm going to kind of dive into some of the key concepts around the EC2 container service and define some terms that you might have not known that we kind of invented. So key components. So we start off, we have Docker as our base runtime. So everything that you run in EC2 container service is a Docker image. Above that layer, we have four new concepts that we have defined. We have clusters, we have container instances, tasks, and containers. So to start at the first one, clusters are a regional concept. So you'll create one or more clusters per EC2 region. And this is your resource pool. So you launch container instances into your cluster, and you now have memory, CPU, ports, and other schedulable resources available within your cluster. You'll take these container instances. You can start as an empty cluster. You can launch new instances that will grow. And you can also terminate these instances in order to shrink your cluster's capacity as necessary. So what is a container instance, and how is it different than an instance? And a container instance is an EC2 instance with two special things on it. It runs the Docker daemon, and it also runs the Amazon ECS agent. Right now, there are two AMIs available. There is an Amazon Linux-based AMI that you can use, which already has these two things installed, and there's also a CoreOS AMI as well. The Amazon ECS container agent is open source on GitHub under Apache 2.0. So if you want to check out the source, or if you want to take the agent and install it onto your own AMI that you prefer to use, you can do that as well. So now that we have container instances that are checked into our cluster that provide us with resources, we need to have something that we're running or executing on these resources, and that is tasks. Tasks are a level above containers, and so it's a relationship of one or more containers that run on a single container instance. A really good example of this is something with a database and something maybe serving content on top of the database. The two containers are linked together, or they could not be, but in general, most of the time you'll want them to be linked together, and this will provide you with kind of an application. So tasks are defined with task definitions, and this is an example of a linked task definition. So on the left-hand side, we have a WordPress application, and on the right-hand side, we have a MySQL database to back WordPress. Starting at the top, some of these arguments will look familiar. They're very similar to what you would provide to Docker. You provide memory and CPU measures, which I'll go into in a little bit in a second. You provide links to other containers, commands and entry points, as well as environment variables and port mappings. So to start from the top, the image, we provide MySQL, as we don't provide any repository. This is pulled from Docker Hub. The CPU units is 10, And so 1,024 units is a full CPU. This is very similar to what LXC does by default. Memory is in megabytes. We have 500 megabytes of memory allocated to this container, some environment variables, and then we also have no ports exposed. On our WordPress side, this is also pulled from Docker Hub from a community image. Our task is marked as essential, which means that if this particular container dies, then the complete task will be terminated, because you don't necessarily want to be running MySQL after your WordPress terminates. It's linked to our database, and we have some port mappings, so we can expose it to the host and to the internet. So that's kind of an overview of the components that we have built on top of. And so here's 3 ways that you can use our service to start tasks. So the default way, or one of the most direct way, is to call start task, and you place it directly onto a container instance. So here I would have my cluster as my default cluster. I have a task definition of ECS marathon, and I'll actually be showing this in a second. And we have a container instance, and you will just give it the container instance ARN, and it will be directly placed onto that instance. However, you're running in a cluster, and you don't want to treat every instance as special. So we have a run task API, which allows you to run your task wherever there is resources available. So if your task has ports, if it has CPU and memory constraints, we'll find a spot for it within the cluster and launch it. Right now, the scheduler is using random scheduling in order to place your task within the cluster. So it will retry until it finds. And then the last option is you can bring your own scheduler. And what we mean by this is you can use the start task API of directly placing your tasks onto a host. And you can use the describe cluster and describe container instance APIs in order to view a state of your cluster. And here we have custom scheduler and Mesos scheduler. And I'll be showing an example of where we wrote a custom scheduler driver that implements the API used by Mesos so that we can power Marathon. So with that, I'm going to jump into the demo and try to juggle the microphone at the same time. We're back. All right.
You can put it down. As long as you speak a little louder.
All right, so I'll talk pretty loud then. So I'm just going to use the AWS CLI here. So let's start off. I have a profile of demo, which provides me with same defaults and credentials. No one saw that. So we're going to call ECS now, and we're going to call create cluster. This is going to create a default cluster in which I can then look and I can see list container instances, and which will assume a default cluster is provided. And I'll see I have no container instances launched. So let's go ahead over to the console, and we can go to EC2. And let's go ahead and launch instance. So I have an AMI right here that I have bundled. It is the Amazon Linux ECS enabled AMI with the Marathon container downloaded in order to speed up the boot time, since it is pretty large of an image. So I'm going to launch it on a T2 medium. For ECS, you need an IAM role that provides the agent with access to talk to the ECS service. And I have this IAM role available right here. I'll just use 30 gigabytes of storage, which is the default free amount for SSD-backed instances. And I'll select some existing security groups that I've set up. So I have one here for default. I have one for Marathon that gives me access for my egress IP ranges to port 80 of it. And I'll add SSH access as well. And we'll add registry access.
Can you
Oh, sorry. Yes. So now we have our first instance that's being launched in the cluster. So we had a 0 cluster size. And once this finished booting up, our agent will launch and we'll add it to it. I'm going to launch a couple other additional instances into our cluster as well. And I'm going to actually just use the default ECS AMI, which you can find by searching community AMIs and finding the Amazon AMI for ECS Optimized Preview 2. I'm still going to select T2 medium. And we'll launch 10 of these. And since this one doesn't have the Marathon image downloaded, we don't need the Marathon group. And we'll go ahead and launch it. So now we should have 11 total instances being added into our cluster. We have one of them that's a bit different than the others, which has some pre-downloaded Docker images. And then we have all the rest are just running the ECS agent and don't have the images downloaded. So because we have one special image, I'm going to use the start task API in order to place my Marathon Docker image onto this host. And so we can see this one is running right here. So we'll go back to the console. And we can do a list container instances, and we see that we have our first one checked in. So I have a couple helper scripts here that help me associate the instance with an EC2 instance, and we can see that this is the same 157E that's running the Marathon. And what this script is it's just a chain of a couple AWS CLI commands. So from here, we can look at our task definitions that we have registered already. And you'll see I have 2 versions of a Docker registry. I have 3 versions of Marathon and 2 versions of WordPress.
I'll try to hold it for you.
So from here, I'm going to go ahead and do a start task. And I'm going to give it a task definition of ECS Marathon 3. You'll notice I can either use the whole ARN in order to run the command, or I can use a thing after the task definition or after the slash. And then I can give it a container instance to launch onto. And I will give it this one right here. So the task is now pending being launched. And we can go ahead and let's get the instance IP. And again, this is just AWS console commands being chained together. And so let's take this, go back to our web browser, and give it a second. So let's make sure everything started OK. So we can do Docker PS, and we see we have Zookeeper running, we have our ECS Marathon running, and we have our container agent all running a container. The task definition specified that Zookeeper and Marathon were linked together, and that Marathon is internal port 8080 is being exposed on port 80. And so let's try this one more time and see if it just took a little while to boot up. There we go. So now we have Marathon running. It's using a custom scheduler driver, as I mentioned before, instead of the standard Mesos driver in order to run our Docker applications. So we can go ahead now, and I have 2 files here. One is registry and one is WordPress. And I'll show you what this looks like. And so this is passing into the localhost 80, which is Marathon, a new application, which is our registry. And the command here is Docker registry, which is the same as our task definition that we have registered. CPUs here is 1 and memory is 512, which is identical to what we have put into our task definition. And so I'm going to go ahead and run this. It's going to curl Marathon. If we go back here, we see registry pop up. And it has started deploying already. So you'll see this, it's being deployed to this container instance. If we go back to our command line, we can exit out of here, and we can do list tasks. And you'll see we have our Marathon that we initialized from our command line, and then we see we have Docker registry here that we've now started up from Marathon. So from this, I'm going to go back to the console, and I'm going to go down to my load balancers. And I'm going to add those instances that I've launched into load balancers. And if I look at what I have here, I have a health check on port 5000 v1 ping. For those of you who are familiar with the Docker registry, this is the health check for the registry. And so what this load balancer is doing is looking at all of our instances for what's running on port 5000 and seeing if anything responds to ping. It's going to take a little bit for it to get out of the pending state and initialize. But then as we launch new registries, they'll become available from our load balancer. So I'm going to go ahead and actually scale this task up from Marathon. And I'm going to change it to 8. I press OK. And what Marathon is doing is it's communicating with ECS using the state of the cluster and running start task commands where it needs to in order to avoid port conflicts and memory and CPU conflicts. And so now we have 8 starting. We can go back again just to show you that this is actually happening on ECS. We can list our tasks. And now we see we have many more Docker registry 2s that are starting up. You'll notice that because they're all running on port 5000, they're all getting bound to different container instances to avoid the port conflicts. And so I'm going to take a bit of a sidestep and show you the last way to run things, which is the run command. And then I'll go back to the load balancer to show you what that looks like. So going back to our task definitions, I have this WordPress task definition that I mentioned earlier. I'll grab the full ARN this time. And I'll just sorry, this is not my computer. We had to do a last-minute change, so I'm not quite used to the setup. And so here you'll see this is just like I had in the slides. We have a WordPress task definition that has a database of MySQL, and it has a WordPress running. And so here I can go ahead and do a of WordPress 2. I didn't put the demo profile, I'm sorry. And now we have WordPress that's being scheduled from the random scheduler that I mentioned before. And we can do the list tasks again. And we can now see that WordPress has found its place on a container instance. We can go ahead and get its IP address. Go back to Chrome. So it might take a little bit to download because the image was not cached locally. And so it's going to be pulling from Docker Hub from that container instance. And so let's see if our instances for our registry have come up. So you'll see now we should have 8 in service, and we have out of our 11 instances, so we have 3 out of service now. And so if I go ahead and grab this DNS name, I feel like there's a better screen when it's not so big. We can come to our laptop and we can do a Docker pull from our registry, and I have a stored image called agent.
I feel like it's downloading layers, but we're not seeing it on the console.
Yeah, I'm not sure what's going on here. So let's try just one more time. Sometimes I've had some issues with the registry with boot to Docker. So. All right, so let's try this. Let's go ahead and get a container instance IP from something that's running the Docker registry, and let's try to grab it locally from there. So let's get the IP. And so we can do a Docker pull. We can grab the full address. So it doesn't like the insecure registry. So let's we can do localhost instead. And the agent downloads. And then back to our WordPress, this thing should be set up. And so we hit the WordPress admin install. So overall, right now we have Marathon running that's managing our registry tasks that can scale up and scale down. We have WordPress running as well in our cluster. And we have Marathon running on a particular node with start task. And so we can just go ahead. We can scale these down to 0 and kill them all. We can go back here, endless tasks, and see that they're all gone. So we're back to just the WordPress and Marathon. And that's it.
Should you show any remote credentials?
Yes. We'll do that right now. Back there.
Yeah. This should be fun. See, I just want to say a couple more things. So, so the preview is open to any customer. We used to have a form that you needed to sign up, use to sign up for the preview, and we'd give you access. As of this week, that's not required. Every AWS customer has access to the preview, so just go ahead and start using it using our CLI. We don't have a console yet, so it's all SDK and CLI. I think all our SDKs, even including, I think this as of this week, the Python one will support the container service. There's no charge for the service. You're only paying for the other AWS resources that you use. So any EC2 instances that you're using, or if you're keeping images up in S3, you pay for those, but not for the service itself. And as one of the other things I wanted to make sure was we're just getting started. There's a whole bunch of things that we want to do. We've been getting great feedback ever since we launched the preview. And if you start using the service and there's certain features that you want to use, drop by the forums, let us know. We are working towards getting this thing to general availability as fast as we can. And we love the feedback that we get. And I don't know if you have time for questions.
Yeah, we do. Could you want to hit the keywords? Maybe across the screen again?
Every slide with an image kills the.
Yep, that's good.
Yeah.
That's good.
Yeah. Anyway, this is the last slide. So we have time for Q&A. So I'll take some Q&A. Dan can answer the hard ones. Go ahead. Sure. Stand that corner.
As far as pulling from Docker Hub, can you pull? I believe I've tried, and I don't believe you can pull currently private Docker repositories. Is that correct?
That is correct, and that's temporary. That's actually one of the most common. Oh yeah, sorry. The question was that right now from Docker Hub you can't pull from private registries. Is it correct? And the answer is yes. Today you can't, but that's one of the things we're actively working on. I think so in the next coming weeks, couple of weeks or so, that's something that you should be able to do. And there'll be a bunch, by the time sort of over the next few weeks, we'll, going into GA, we'll actually publish some other ways that you can use private registries either inside AWS using S3 or putting things in Docker Hub and how you can use that. Yeah.
Thank you.
Go ahead.
Yeah, from an API perspective, how open are you guys going to be to third-party products like a Kubernetes or something else on top of the service, or are there only private reserved features in certain?
Yeah, well, you saw a great example. We were using, so we don't use, we were using the Mesos front end. So sorry, the question was how open. Thanks for reminding me. The question was how open are we to using other kinds of APIs and other frameworks with the service. So our general assumption is that what we really are interested in is the back end and managing the back end. And the reason we chose to build sort of this, give you a full state service was that you can integrate it more easily with other platforms. So the Marathon demo that you saw uses a Mesos scheduler driver that we have, which we just open sourced. Essentially, it converts our state responses into an offer, a Mesos offer that Marathon understands. So you're not running any Mesos masters, you're not running any slaves, but you're using Marathon. You can use Chronos. Those are the two that I've tried. Probably any Mesos scheduler will work. You can. Our hope is that other people do similar stuff, which is integrate this with the other front ends that you care about, and we expect people to do that, and actually we want people to do that. Any other questions? Go ahead.
Are you going to do any extra support on container networking to kind of boost a little bit of the container-to-container networking?
Yeah, the question is, what are you going to do about container-to-container networking? Do you have plans to support additional features? The short answer is yes. We are still trying to figure out what are the things that people want us to do, what are the things people care about. It's early. We have a list of feature requests that we've gotten. We start evaluating those. So keep an eye out for those. One of the reasons we chose to go VPC only was partly for network isolation reasons, but it also allows us to do interesting things at the networking level. Go ahead.
Any internal clients yet?
As in?
Internal Amazon clients.
Yes. The question is, are there any internal Amazon clients? And I'll just say yes.
Are there any what?
Any internal Amazon services using our service? And the answer I gave was yes. Additional questions? Going once, going twice. We'll be around. So this little corner over here is the container service team. So, go ahead. Sorry.
As far as monitoring containers, do you guys plan on building anything like that into CloudWatch or anything?
So the question was about monitoring containers. Do we plan to build anything into CloudWatch? And actually, that's something we are actively working on. As you can imagine, one of the interesting things that we could do is send cluster-level features into cluster-level metrics into CloudWatch that you can take actions on, like changing an auto-scaling group, for example, and triggering your host environment. So that's definitely on the cards. Okay. Yeah. All right. Thank you very much. And as I said, there's a bunch of us sitting over here. Happy to take questions or talk to you later. Thanks.
Thank you. You want to hold off for a second?